Hey there, in this video we are talking about pointer variables in C++, and this covers sections 9.1 and 9.2 in the Gaddis C++ book. So pointers, an incredibly important, an incredibly fundamental topic in computing and how computers work. Now I know that for a lot of people, the first time that pointers are introduced, it's a very confusing subject. And in fact, I'll say it was for me the first time that I ever saw pointers in my college programming course. And I feel like part of the reason for that is that it's commonly brought up right at the end of first semester programming. So what happened for me is right in the last week of my first course, there was a moment where the instructor was, hey, here's pointers. And I was very much left hanging about why on earth would you ever want to use them or do that until a later date. And I've talked to other people that have had the same experience in life. So where I teach at CUNY Kingsborough, we introduce pointers basically at the start of second semester programming. And personally, I think that's a much better way of doing it because we are going to get a whole semester to practice and reflect and see more applications of pointers. So I think that we will get a much deeper understanding about what they give us in programming. So personally, I get very excited about the opportunity to introduce people to pointers the right way. And here we are. We get to do that here in Chapter 9. Okay, so here is a review slide about how memory addressing works in the main memory of a computing system. And for what it's worth, this slide right here, I present on the very first day of my Programming 1 course when I teach it. This picture here is in the Gaddis C++ book in the first chapter. And so right after we introduce the very first ideas of computer hardware, and there's a CPU, and there's main memory, and there's a hard drive and stuff like that, we say, we're going to have to be aware about how the main memory is actually set up. There's a whole bunch of bytes in the main memory where the data is stored when programs are actively running. And like on my system, has about 16 gigabytes of memory. That's about 16 billion bytes or so. And how that's tracked is that every single byte has what's called an address, has a unique number identifying where this byte is in memory. And so on this picture, we have a teeny tiny little slice. There's only 30 different bytes shown here. And the little flag in the top is meant to indicate the address. And of course, the addressing starts at number 0, is the very first byte in the system. And this picture goes up to about 30, whereas in reality, it would go up to about 16 billion on my current system. And you can see that these bytes are places where you can store data. And as software programmers, we're probably going to think of those as numbers. And you can see in this picture here, byte address 16 is currently storing the number 149, whereas byte number 23 stores the number 72. So this is something we introduced the very first day of the programming classes that I teach. And we say most of the time, C++, the compiler, will be handling this for you. When you make a new variable, it will get part of the main memory system, and behind the scenes, it's going to be tracking the address of where that data has been put. But here in the advanced programming course, we are in fact going to have to deal with that issue directly, and now we get to start dealing with the addresses ourselves for somewhat more advanced topics. Okay, so here's the basic idea of a pointer. A pointer is a variable that's going to hold the memory address of where another variable or data structure is sitting in the main memory. So a variable, and all data is numbers, of course, but it's not intended to store data itself. It's storing the numerical address of where something else is in the system. Commonly, people say that a pointer variable points to the other variable. It's going to tell you where it is if you look at it. So here's a graphical representation of that. On the right, I've got a normal integer variable called num, and we have saved the number 25 in it. Now that's somewhere in the memory system, and normally I don't know where. Today we're going to be able to find out. So keep in mind that when you see addresses, addresses are normally printed in hexadecimal, and in C++, if you see a number starting with 0x, that's the tag saying, hey, this is actually a hexadecimal number. So for argument's sake, and if we did this in practice, I'm sure it would get put in some other location. But for argument's sake, let's say that num is sitting in the memory system at address hexadecimal 4A00. You might ask, why does that get printed in hexadecimal? It's actually somewhat more convenient for programmers. If you've never heard of that before, I do have a lecture video for first semester programming that covers topics like binary numbers and then immediately starts talking about hexadecimal numbers. And the main point is just that it's shorter. It's a shorthand if you're thinking about binary bits. And that's why programmers like hexadecimal. It's just a shorter way of talking about it. So anyway, let's say that that is the address where this num got put. And now what you're going to see is we're going to create a pointer variable. It's going to be called int ptr, int pointer probably, and it's going to hold that address, right? And if for some reason you need to know where the num variable is, you can look at this int pointer and it points to, it tells you what the address is. That's the basic idea of pointers. Okay, so for example, here is, why are pointers key in computing? So on this slide, I'm pointing out a little bit about how central processing units are set up, how they're actually physically designed. And so there's a small number of data storage locations on the CPU that are called registers. There's only about 24 of them. It's a very small, limited amount of space on the CPU, and that's why you need the larger main memory to store most of the data while programs are actually active. The CPU itself is actually very limited, only about 24 locations called registers. And here on the right, there's actually a picture of the registers on my x86 CPU. So this is actually brought up in Dev C++. You can get a picture of this in Dev C++ version 6. If you debug a program, you run it in debug mode, and then click on Debug View CPU window, and it will show you these registers actually. And you can see that the registers all have their own name. I mean, just for starters, RAX, the very first one, stands for the register for accumulators. Accumulator variables are supposed to go there. I've sliced off the next column over that would show you what's actually sitting in these registers during this particular program flow, but that's not important for this issue. The important thing is that some of these registers are dedicated specifically for handling pointers. And the first one here, RBP, that stands for the register for the base pointer. And what that's going to do is it's going to hold the address of the start of the current data frame. What's a data frame? Well, when you get into a new function, you have to store the local variables and the parameters that are coming in and the return address about where you need to go back once this function is done. That's called a data frame, all the local variables and parameters and return address. So whatever current function is running, this RBP is specifically going to store the address of where that data frame starts for your current function call. And then the next one, RSP, right, that stands for the register for the stack pointer, and that's the address of where the current data frame ends. So between those, you've got the start and the ending of where the data is for your current function call. And then down at the bottom, there is a register that's called RIP for the register for the instruction pointer, and that is the address in the memory system of where the next code instruction is going to come from. Right? You have a program, it's been compiled, it's a whole lot of statements. How does the CPU keep track of where the next statement is coming from? Well, there's a dedicated register in the CPU just for that, and that's always going to be storing the address of where it needs to look up the next instruction. And basically that's how it keeps track of, I'm going through your program line 10, 11, 12, 13, 14. Right? The address of where it is sitting in the RIP. So the lesson here is that pointers are super fundamental to just how computers work. Right? Keeping track of where the data is currently, keeping track of where the code instructions are coming from, that has to get built into the core of the CPU. And if that wasn't there, if it wasn't handling those pointers for us about where stuff is, nothing could possibly work. Now, I'm kind of stealing these ideas from another class. This is probably not normally part of a Programming 2 course. So these ideas would get fleshed out more probably in a computer architecture course or an assembly language course. At our school, that's CS 1400 at CUNY Kingsborough. But I feel it's important to realize that when we talk about pointers, they are actually a thing that's physically built into the CPU about how it runs. So this is sort of the low-level story, right? This is what happens on CPUs. Pointers are super important. But here's the high-level story, right? As C++ programmers working in a high-level language, when is this actually going to be important to us? And I have 4 bullet points here about things we're going to do in the future that require use of pointers. So item number one, it allows you to pass large data structures between functions without copying. Remember, normally the default for parameter passing is to pass by value and make a copy of the data that you're working on. Well, as we work on larger and larger data structures, we certainly want to avoid that and not be wasting a whole lot of memory. So instead, what you can do is you can pass off the address and a pointer and say, this big block of data that I'm working with, here's where it is. Here's the address of where it is. I don't need to copy it for you. You can just go look it up yourself. Now, you might say, isn't that how passing by reference works? And the answer is yes. And the thing is, how passing by reference actually works is it's using pointers. So personally, when I started learning C++, passing by reference didn't exist. And the only way that I could do that job of passing a large data structure without copying is I had to use the pointer directly. Nowadays, the reference parameters with the ampersand are basically hiding the details of the pointers, but that is actually how reference variables do their job. So we should know about that. Secondly, pointers are commonly used in algorithms on arrays and strings that we'll be looking at in like around chapter 10 or so. A lot of those classic algorithms are working with pointers about where stuff is in the memory. Third, and for me, I think this actually might be the biggest item, is that it supports dynamic memory allocation. What is that? Well, we've been writing fairly small programs so far with fairly small amounts of data. But on the day when you want a much larger block of data, like I want 10 megabytes of data for something, or I want a gigabyte of memory, the techniques that we've used so far simply won't work. A big block of data like that will not fit in the data frame that you're making for a normal function call. So if you want to go to your operating system and say, I need a giant chunk of data, you can do that. But in order to do that, you need to use pointers, because the operating system is going to come back and say, hey, I found you a giant block of data. Here's where it is. Here's the address of where it is, and that's a pointer, and that's what you're going to have to deal with to interface with that system. So for me, that's hugely important. That's actually the next video. I'm going to show you the details of that in the next video. And then the fourth bullet point here is that, the main goal of this second semester course is to get to use object-oriented programming, and that's up in chapters 13, 14, 15, 16, stuff like that. And pointers are required for some of the advanced aspects of object-oriented programming. So hypothetically, you could jump up into chapter 15 and kind of browse it at this point, and you would see a whole lot of use of pointers to make use of these advanced techniques in object-oriented programming. So a whole bunch of applications that we'll get to practice throughout the course of our second semester programming course. Those are things in the future. So to begin with, we should just be able to make pointers and use them. So just what's the fundamental basics in C++? So first of all, if you want to get the address of a variable, right, we know that every variable in a program is stored at a unique address, a particular location in the main memory system. What you do is use the address operator ampersand to get the address of a variable. Use ampersand to get the address. So for example, a very short example here, if I make an integer called num and I initialize it to -99, right, here's the ampersand on the next line. I want to see the address of where num is, like we said before. So I can print out ampersand num, and you're not going to see -99. You're going to see the address in hexadecimal of where num is. And that's how you do that. Okay, again, just getting the address. Now, what we want to do with pointers, when we talk about pointers, we want a variable to store that. So let's add that to the picture. So here is how you declare a pointer variable, a variable specifically to hold an address. You're going to see the asterisk there, indicates you're dealing with a pointer. So I would read this line as I'm making an integer pointer called int pointer. Right, I would actually read the asterisk as pointer. I'm making an integer pointer called int pointer. Now, for its worth, you've got to have that asterisk there. The spacing actually doesn't matter. So some programmers are going to put spaces around both sides of the asterisk. Some people put the asterisk right next to the int type there. I personally do that myself because I feel that it makes it a little bit more obvious what the type is specifically. Unfortunately, if you want to declare more than one variable on one line, like with commas, you do have to put the asterisk in front of every single separate variable. Might not have been the very best thing to do in the world, but that's how C++ works. So just to be perfectly clear, right, this variable that we just declared, if I come in someday and I ask, what's the type of this variable, right, what is the type of this variable? What's the answer to that? And the answer is integer pointer, right? This is not an integer variable. That would be a different type. The type of this is integer pointer. And they are meant to store different things, right? And just for starters, they're different sizes. Like on my system here and the system in our labs, an integer, if you recall, takes up 4 bytes for the number. But an integer pointer, totally different thing. In fact, it's a different size. It takes up 8 bytes on our system, which is to say 64 bits, and it needs to do that to interface with our 64-bit operating system. Okay, so kind of be careful about that. They are different types, they're different in a lot of ways, and just for starters with, they're probably different sizes. Okay, so once you've declared that, right, then you can assign into a pointer variable the address of some other data structure. So here we have made an integer pointer. We've called it int pointer, just like the last slide. And then on the next line, we are assigning into that pointer the address of where num is. And now we have the situation we saw in the very first slide here, where I've got num holding some kind of value, and whatever location it is in the main memory, we have stored that in the int pointer. And again, we would say that int pointer is now pointing at where the num variable is. And now you've accomplished that. So here is an example program 9.2 in the Gaddis book, and the point of this very short program is this program stores the address of a variable in a pointer just like we said. So on line 7, we're going to declare an integer variable called x, store something in it, like 25. On line 8, we're going to declare an integer pointer. We named it PTR because it's a pointer. A lot of people do that. On line 10, we're going to store the address of x in the pointer, okay? And then on line 11, we're printing out the value in x is x, right? And as you can see here on the bottom here, the program output, that's going to print out the 25, the number that's actually stored in x. And then on line 12, we're going to print out the address of x is whatever's in PTR. And you're going to see a hexadecimal value for where it is in the memory system. You should try this at home, right? I am sure that the address of x will be different for every different person. Depending on what applications are currently running, depending on what memory is available, the data frame that holds the x, where it is in memory, could be in many different locations. So you'll probably get a different address, I'm sure, but you'll see something and it will be in hexadecimal because that's by default how addresses get printed out. Okay, and there's the difference between the value in x and the address of x. Okay, so having done that, now having a pointer, how do you get back to that value? And what you do for that is, again, you use the asterisk in a different way, and this usage is called the indirection operator. So the indirection operator, asterisk, dereferences a pointer, right? You can talk about a pointer being a reference, where something is, and if you want to go look it up and retrieve the contents, you have to use the asterisk again right before your variable, right before your pointer variable. So this is how you can access the item that the pointer points to. So just to expand that example a little bit, you make an integer called x and give it a number 25. You make an integer pointer called int pointer, and you give that the address of where x is. And now if you print out star int pointer, right, dereferencing int pointer, that actually gets the 25 back. Right? So you're taking int pointer, saying follow that address, right, over to where that is, and go dig up what the contents are, and that's how you can get the 25 back using the pointer variable. Right? Again, a very simple little example. You might say, why didn't I just use x directly in the first place? But for those different applications that we'll be dealing with later, like dynamic memory allocation or object-oriented programming or stuff like that, you will only have the pointer. Right? You will not have direct access to a variable called x. You will only have the pointer. So in order to get at that data, you'll have to be able to use this dereferencing operator. All right, another thing that you can do with pointers, and this comes up in the first lab that we do in our class actually, is you can use relational operators like less than or equal to or greater than or equal to compare addresses in pointers. Again, they're really just numbers. So you can use relational operators to compare those, but be careful about that because comparing the addresses of where these things are is different from comparing the values that's sitting in those locations, right? So for example, this first example, if, and these are, PTR1 and PTR2 are both declared as pointers, writing if PTR1 is equal to PTR2, that's comparing the addresses, right? Those are pointer variables holding addresses. So that's going to determine whether this pointer is actually the same place as what this other pointer is talking about. Are they the same place? And if so, obviously they're holding the same contents because they're talking about the same place. But this second example, right, we're dereferencing PTR1 and seeing what the contents are. We're dereferencing PTR2 and seeing what the contents are and comparing to see if they are the same. So pointer 1 could be one location and pointer 2 could be a different location. And here we're checking out, are you storing the same number in two different locations? Okay, so big difference. And when you do the first lab, if you're one of my students, be really careful about whether you're comparing the locations versus comparing the contents of those two different locations. Great. So that's a pretty good introduction to pointers. So you can make a pointer in your C++ code now. You can get the address of a variable. You can store it in a pointer. You can print it back out by dereferencing it. And you can even compare two pointers for how they are located in the system. Or you could compare the contents, right, by dereferencing them and comparing that instead. So at this point, we do an initial lab on pointers. And the point of this program, very, very simple. It's not like it does really anything interesting. Is just to get some practice with our fingers typing the ampersands and the asterisks for pointer syntax in a C++ program. So we do it once and twice and 3 times and 4 times and get a little bit of practice, just our fingers and our eyes seeing and feeling that in the code. And then we can go on next time and we can do more interesting things. Now, the more interesting thing that we are going to do next time in the next video is specifically dynamic memory allocation. And to me, that's the big payoff of pointers. When you need a big block of memory because you're doing something really major on the computer system, you have to go to the operating system, you have to request a bigger block of memory, and the operating system is going to come back with an address saying, here's where it is. I found it for you, and here is the address of where your block of memory is. You better save that in a pointer so you can use it later. So that is a huge and, to me, very interesting subject next time, and I will see you then for that.